This time, we're going to add or subtract mixed numbers. Now, in these problems, I'm going to do each one of the problems two ways. I'm going to do it a traditional approach that says you're going to add or subtract the fraction parts and add or subtract the whole number parts, and then carry or borrow as you need to. But I'm also going to do an example where you change them just like you did multiplication or division into improper fractions. So let's take a look at some of these problems. Okay, the first one is an estimate. So I have 5 3/8. 3 is not half of 8, so this is smaller than a half, so I'll keep that as 5. 7 out of 9, though, that tells you to bump that up, so I'll bump that up to 5. So the estimate for these will be 10. So sometimes it's very useful to be able to figure out an estimate in your mind if you don't have to have an exact answer. All right, number 2. I'm going to take a little time to do this because I'm going to do several things. I'm actually going to do part B first, and then we'll do part A twice. All right, 11 out of 27. Well, 11 is less than half of 27. 11 is half of 22. So this is less than half. So for the estimate, I would drop that. 1/9, 1 out of 9 is less than half, so I would drop that. So for an estimate, all I would be doing is adding 11 and 20 for 31. Okay, because both of the fractions are less than half. So that would be my estimate. Now I'm going to do exact, and I'm going to do it twice. I'm going to do it the first time, leaving them mixed, and then I'm going to do it changing them to improper. And it will be your choice which way you want to do it. There are pluses and minuses to both of them. All right. If you're going to leave them as mixed numbers, you still have to think about a common denominator, which is 27. So this is 11 and some 27ths. We're going to add to it 20 and some 27ths. 27 goes in there once, which means it's 1 times 11, or 11. 9 goes into 27 3 times. 3 times 1 is 3. I'm going to add these up. I'm going to add the fraction parts for 14 27ths. I'm going to add the whole number parts for 31. And for that problem, it was not at all bad to do it that way. Now, the way you could do it improper makes the numbers larger. So what I'll have to do is take 11 and 11 27ths and make it be improper. 27 times 11 plus 11. Whoops, made a mistake. 27 times 11 plus 11 gives me 308 over 27. See how large that got? I'm glad I had my calculator. I have 20 and a 9th. 9 times 20 is 180, plus 1 is 181. Now that's still over 9. So I then have to get a common denominator of 27. No change for the top one. 9 goes into 27 3 times, and 181 times 3 gives me 543. Okay, and now I'm going to add them. This was all addition. So I have 543 plus 308 gives me 851 over 27. Unfortunately, that is an improper fraction, which would not be acceptable. So I'll divide 27 into 851. And I get 31 and a decimal, which I throw away. So now I have 31 times 27 gives me 837, and subtract, and I will get 14. This was a lot longer, but I got the whole number 31 and 14 27ths. That should look familiar. It's up here and it's down here. In this problem, I feel very strongly that the mixed number process was the shorter one. All right, let's look at the next one. All right, if I do, in this one, I'll do mixed first. So I have to get a common denominator. So I'm going to have 20 and some 14ths, 8 and some 14ths. 7 goes into 14 2 times, and 2 times 5 is 10. No change here. If I add these, I get 28 and 19 14ths. Now, the problem with that is that I've got a mixed number, but the fraction part is improper. So what I have to do is take that 19 14ths and say 14 goes into 19 one time with 5 left over. That is 1 and 5 14ths. So I have 28 plus 1 and 5 14ths, or 29 and 5 14ths. So I had to do some carrying. Some people don't like to do that. They are uncomfortable with it, and they would prefer to do it improper. But the numbers are going to be big. So I have 20 and 5 sevenths, 8 and 9 14ths, and I'm going to make them both be improper. All right, 7 times 20 is 140, plus 5 is 145 over 7. The next one, I have 14 times 8 plus 9 gives me 121 over 14. Common denominator is 14. 7 goes in there 2 times, and 2 times 145 is 290. No change down here. So now I add 290 and 121, and I get 411 over 14, but that's improper. So I have to divide. I'm using my calculator off screen, and I get the whole number 29 and a decimal that I throw away, and then I multiply 14 times 29, which gives me 406. I subtract for 5, and I have 29 and 5 14ths. So yay, same answer. It's your choice. All right. Next one. Find the exact difference and an estimated difference. Let's go ahead and do this estimated. 11 is more than half of 14, so I'm going to change that to 10. Then I'm going to subtract, well, in fact, I'm going to write it over here. Estimate. This is 10, and I'm going to subtract. 1/7 is less than half, so I'm going to throw it away. So it's really just going to be 10 minus 5, which gives me 5. The estimated difference is 5. So I've gone ahead and done that, even though when you do it in Math Lab, that may be the second part. All right, now, to do it as exact, let's do them as mixed, which means I'm going to leave it as it is. First thing I need to do is get common denominator. This is going to be 9 and some 14th, and I've got to subtract 5 and some 14ths. 14 goes into 14 once, and 1 times 11 is 11. 7 goes into 14 2 times, and 2 times 1 is 2. Because I can subtract, this isn't bad. I have 2 from 11 gives me 9 14ths. 5 from 9 gives me 4. And I'm done. So that wasn't bad. If I decide to do it as improper, I'm going to have to take this first fraction and say 14 times 9 plus 11 gives me 137 over 14. And I'm going to subtract 7 times 5 is 35 plus 1 is 36 over 7. But I don't have a common denominator. Common denominator is 14. No change for that fraction. 7 goes in there 2 times, and 2 times 36 is 72. So now I have 137 minus 72, which gives me 65/14. It's improper, so I'll take 14 into 65. I get the whole number 4 and some decimal, which I'm going to ignore. And 4 times 14 gives me 56. And I subtract for 9, so there's my 4. Ooh. That was certainly hopping around, sorry. That's my 4 from up here, and 9/14. There's the 9, there's the 14. Same answer, done with improper. Lots of times, just keeping them as mixed numbers is the faster way. The only time it gets a little tough is when adding, when you have to carry, and in subtraction, we'll probably see that we need to borrow sometimes. And here's an example. I need to subtract. If I keep it as it is, and I do these as mixed, remember I'm doing every problem twice. If I do it as a mixed number, well, I can't take 1/8 from nothing. I have no eighths up there. So in this case, I'm going to need to borrow, just like if you needed some change and you went up to somebody who only had dollar bills and said, can I borrow $2 and some change? They'd say, well, let me get one of my dollars broken. So I'll keep 8 wholes because that's one less. Now, what do I put this as? Well, the number 1 that you've borrowed could be 1/1, 2/2, 5/5, 9/9. But because you want the denominator of 8, it's going to be 8/8. This 8 is because it's 1 less than 9. This 8/8 is because of this denominator. Now I'm going to subtract 2 and 1/8. I can now subtract. That gives me 7/8, and that gives me 6. 6 and 7/8. That's what it's like to borrow. Now if I go improper, I don't borrow. I call that 9/1, and 8 times 2 is 16, plus 1 is 17/8. Common denominator is 8. 1 goes into 8 8 times. 8 times 9 is 72. No change here. Take 72 and subtract 17, and you get 55/8. Divide. It's going to go in there 7 times. Well, it's not, sorry. It's going to go in there 6 times for 48, and then subtract for 7, and there it is. There's the whole number 6 and the fraction 7/8. It's a little longer with improper. Did not involve borrowing. Okay, last one. Oops. All right. Let's do it mixed. So I'm going to get a common denominator. This is 16 and some 18ths. I'm going to subtract 3 and some 18ths. 9 goes into 18 2 times. 2 times 7 is 14. No change here. Now, here's an issue. I have 17/18 and I need to subtract it from 14/18, which I can't do. So I'm going to borrow from the 16, making it a 15. If there were nothing sitting here, the one I borrowed would be called 18/18. I'm going to add 18/18 to the fraction that's already there. I have now 15 and add 14 and 18 for 32/18. Subtract 3 and 17/18. Okay, when I take 32 minus 17, I get 15/18, and subtract here for 12. And 15/18 can be reduced. We might not have had to do a lot of reducing. 3 is a common factor, so that's going to be 12, and 3 goes in there 5 times, 3 goes in there 6 times. Now we're going to redo the problem, and we're going to do it with improper fractions. Once again, the numbers are going to get big, but we won't have any borrowing. Okay, I'm going to copy it down. Let's see. I've got 9 times 16 plus 7. So I'm going to start out with, and I guess I've got room right here. I'm going to start out with 151 over 9, and I'm going to subtract 18 times 3 plus 17, 71 over 18. Common denominator of 18. 9 goes into 18 2 times, and 2 times 151 is 302. No change down here. So I'm just going to subtract 302 minus 71. Gives me 231/18. So 18 goes into 231. Using my calculator for some help. It will go in there 12, and there's a decimal, but I'm going to get rid of that decimal. Then I'm going to multiply the 12 times the 18 for 216, subtract for 15. So I have 12 and 15/18. Still reduces. That's 12, and 3 goes in there 5 times, and 3 goes in there 6 times. So you can see it didn't matter which way I did it, I got the same answer. You're always going to have a choice. When you add and subtract mixed numbers, you can leave them as mixed numbers, or you can make them improper. It will be your choice. When you multiply and divide, I'll just remind you that you have to go improper. So, hope that helps.